There, now it's recording. We were just talking about troubleshooting, and Owen's been working on some computers trying to figure out why they aren't working. Well, as he mentioned, the first thing to do is make sure, are they plugged in? Is the power switch on? So a computer starts from hardware. So if there's a hardware piece missing, like if the memory is missing, it's going to make beeping sounds or it won't start at all. It could be the power supply is bad. If nothing spins and nothing happens, it could be the power supply. It could be the system board. Now, if you're trying to determine which of those parts don't work, what might you do to troubleshoot that? Say you're suspicious of the power supply. What might be a good way to see if the power supply is the problem? And this is common in cars too, and anything else you're fixing now. Yeah, Owen.
Try with a good power supply.
Try a known working good. And that's a lot of troubleshooting is like that. You're not sure that that's the problem, but if you swap in something you know works, then you know that's the problem. And that's quite often a fast way to discover. It can be expensive if you have to buy a new like system board. Yeah, maybe not so much. But in our case, in the back of the room, we have a bunch of computers that are fairly identical, and you can swap things around fairly easily and see what's the deal. So the hardware part, first, we have to have power. We have to have power to our system board. We need the power supply working. We need to have RAM. We need to have a CPU. Usually it complains if you don't have a video card. And really, we don't need anything else because the keyboard and monitor aren't needed. I have my servers are running in the back of the room just fine without a keyboard and monitor. I just put my little KVM switch when I need to do anything, which is very rarely. So once you get past the hardware part, then at that phase, when everything is powering up, it's called the power on self test. So there's a good think aloud project. What is power on self test? You power it on the BIOS or the, not CMOS, the BIOS, what's it called now? UEFI. The UEFI tests and says, do I have memory? Do I have a bootable device? Do I have a CPU? Do I have my basic pieces of hardware? That's the power on self test. The next thing that happens after it makes sure it has the reasonable stuff, which is not everything necessarily, doesn't care if it has a network card, doesn't care if it has a wireless, it just needs enough to get started. Then it'll start looking for an operating system. And it's looking for what's called a bootable device, meaning a device that can start the computer. So when we created our virtual machines, we couldn't just say, oh, Windows 11 magic, you're on there. No, we had to find our ISO or optical drive, or it's more commonly a USB drive that contains software that will install Windows, which means set up the Windows files in a way that the operating system will run. And the first thing that happens when you install Windows is it starts up a little bitty tiny version of Windows. So if the machine starts up and there is nothing on storage that'll boot, it'll say, sorry, there's no boot device, I can't go any further. But if we get to that point, how can you tell if Windows is actually starting? What do you see on your computer that you think indicates the operating system is loading?
Well, it usually has like installing Windows or something going on.
Well, we'll say that Windows is okay. It will do, I'm starting up a Windows, and you may not pay attention to it, and you may not see, there we go. So it's starting the virtual machine, we got past the hardware, and then at some point, you're going to see, this is still the hardware getting stuff ready, which is our virtual hardware. And then it's looking for a boot device, which it is already booting a little bit. And then you see the little spinny guy, right? See the little spinny guy? At that point, the operating system is trying to take over. So the hardware said, okay, go ahead, operating system, do your stuff. Find all the devices you need and all that sort of thing. So this chapter is about that part. What happens when our computer gets the go-ahead, when our operating system gets the go-ahead from the hardware to start loading the operating system. So we've already divided things in half. Is it the hardware? Well, we've talked about all the things that we can do with the hardware. Once you see the spinny thing, that doesn't mean that the computer is going to work. It just means the operating system is starting to load. So let's look at understanding the operating system. So the operating systems, all operating systems have two modes. The shell is where we interact with the operating system. So every device has a shell. This is a graphical user interface. This is a graphical user interface. Any device you have can have a graphical user interface, or another one is called the CLI, command line interface. This was like the original one before we had graphics. So those are the two types of shells that we have to interact with the operating system. So the shell is where you do something. It's where the applications run. It's where anything that you click on runs. Like this guy here is running in the application shell. You know, it's an application running in the shell. And there's a reason I'm saying that. Well, is that the one I want to shut down? I think it is. Because I don't need that one right now. I don't need two of them. There we go. So the shell is where you do stuff. Oh, but like everything else we've talked about, everything has layers. The reason we have layers in things is because if I'm a programmer working on the shell, I just have to work on the shell. I don't have to work on the entire operating system. I can work on my little part and get it to work right, and somebody else works on the kernel. Well, actually, when Microsoft is developing stuff, they have all kinds of little different places where people work on things. They might have a whole group of people just working on programming the start button to get it to work. They will have a bunch of people just doing Edge. So the reason we have things divided is, one of the reasons is so developers can work on their little part. So the kernel, and all operating systems have a kernel operating system. The hardware abstraction layer is the part that stands between the operating system and the hardware. Every device, this computer up here has different hardware than this does. And you know how many different Android phone devices there are? There's all kinds of different types of devices. There's all kinds of different types of computers. There's all kinds of different types of printers and wireless access points and all that stuff. So if all this operating system was one big monolith, meaning it's all one thing, we'd have to write a different version of the operating system for every difference in hardware. Does that sound reasonable to have 5,000 versions of Windows? No. So they divide it up into layers, and the hardware abstraction layer is the layer where the device drivers connect to the operating system. And then you can have multiple device drivers talking to the hardware abstraction layer. And if you have a different device, you just plug in a different device driver. So a device driver stands between, let me find my device driver. I think it's right here. There it is, device manager. So all of these, this is what I can see in user mode. I can see that, oh, my Logitech QuickCam may or may not be plugged in. I don't use it anymore because I have the little owl. But all of these will show little files, and we've looked at this somewhere. This is the software. Well, it doesn't show the software, does it, actually? Anyway, this is the software that's between the hardware, and it talks to the operating system, and actually it talks to the hardware abstraction layer. So we can have one operating system and have 5 gazillion devices as long as somebody has written something to go from one layer to the hardware layer. So you're going from the operating system to the hardware. And that's how many devices do. The Android, same thing. Basically, this is a Linux computer, and it'll have a hardware abstraction layer where it'll say, oh, that's the kind of touchpad you have. Oh, that's the kind of screen you have. You're on Verizon. You have this, you have that. They'll put little specific little programs that go between the operating system and that specific device. So they don't have to write 5,000 versions of Android. That's another reason why things are layered. Executive services are actually the operating system doing its business. and you don't ever talk to that directly. That makes the system very stable. So this is where all the really important things happen. You can't interact with that directly. You have to go through the user shell to get to that. And here we go. This is, oh, there's a nice little picture. Don't you like pictures? Let's make that picture bigger. So we have us, users. We use applications. We have user interface tools. So what might be an example of a user interface tool?
Screen longer.
Start menu, file explorer, clock. I want to adjust my time settings. Any of these things are user interface. So user interface means you're doing something to get something started. An application would be, I'm using one right now. I'm using two actually. Zoom, and I'm using PowerPoint, and I'm using VirtualBox. And I guess that's it. I have a command prompt open too. So all of those are programs or applications. This would be an operating system. This would be a, what do they call it? User interface. So here's a user interface tool because I'm using the command line. So then the shell is where everything that we're talking to happens. Then this talks to this through this special little layer that says, okay, well, maybe we'll do this if it meets our rules. If it doesn't, sorry, we're not going to do it. By dividing these pieces up, that makes the operating system very stable. Because we can do stupid things up here. Our programs can crash and burn. It's isolated from the actual operating system kernel. And all modern operating systems work like that. Your application crashes and burns. Most of the time you don't care. You just start it up again. Because you've had your, like web browser, Word or something lock up. Well, you close it, start it again. Everything's probably fine most of the time. In the earlier days, we had much more monolithic stuff. And if the application crashed, it would take out the entire operating system. And I'm talking 20, 30 years ago, like an MS-DOS and all that. And then finally, we have the hardware abstraction layer, and that's where the device drivers talk to all the little pieces of hardware. So I have all these layers going on. They all have to communicate. In Windows, our configuration data is stored mostly in this special little registry file, which is a database of what does what. And we'll look at that later. And then sometimes there's configuration files because, well, my desktop is this color. Your desktop could be a different color. I have different icons on my desktop. All of these things have settings that have to be stored somewhere, and most often they're in the registry. All right, directory structures. Well, now we're going to look at where all those little guys are stored. Remember we were doing let's look at our computer and turn on all the extensions and everything? Yeah, we want to do that because we want to know what's going on. Let's see, I think I have everything turned on. Yep, I do. There's my page files and all that. So if I go down to users, here I am. This is my part of the registry. The registry is divided into two pieces, the user half, the computer half. So computer general settings are stored in the, I can't remember what it's called. The registry is kind of a complicated mess. But you have your particular settings when you log in. So, and when you log into your laptop, your particular settings are stored here. The general settings for the computer are stored in another part of the registry, but they may have multiple files, but the registry is a single item. Yeah. Here's one you may or may not have known. We'll find out. If we have program files and program files x86, which one is 32-bit and which one is 64-bit, or does it matter? Does anybody know what x86 means? How about x64?
Bit rate. Isn't it?
It's what?
The bit rate.
It's the bits of processing. So you can, with a 32-bit program, you can do 32 bits at a time. Yeah. Usually we use bit rate for like something going over a network.
Oh, okay.
Does that make sense? So it's like 15 megabits per second or something.
Yeah.
But that's the right idea. These programs are 32-bit programs. These will be 64-bit programs. Does it matter? Not particularly as far as what you're doing, but when you get up into higher end programming, like you're doing a lot of stuff in Photoshop, you're doing big renders and 3D programs, then it can make a lot of difference. But over time, more and more programs have migrated to the 64-bit part. But there's still some, like the hover cam thing I use whenever I get my hover cam out, uses that. There's Silent Eye, we use that in cybersecurity. Some of this stuff is still 32-bit. Like this advanced IP scanner, it's not going to make a bit of difference if that's 32 or 64. So the amount of things you can process at one time is not a big limiting factor, but over time, things will go more and more 64-bit. So we will eventually end up with nothing that's 32-bit anymore. All right, so we talked about the registry. Okay, we don't need to do all that stuff. So how does Windows manage applications? We've talked about processes. We've talked about threads a little bit as we looked at our task manager. So if you bring up your task manager, right-click on an empty part of your taskbar and bring up task manager, you'll see all these things running away here. And apparently my Firefox is running in efficiency mode. Okay, it limits resources used by the process. Okay, well, that's interesting. Don't know that I remember seeing that one before.
I think that's just a normal thing because my Chrome's in efficiency mode all the time.
Oh, okay. Well, here's another one that's in efficiency. I just have never noticed it. Huh. Interesting. Okay, so we're seeing processes, right? So Firefox has, look at all these little guys. So for a program to do more than one thing at a time, because I can be surfing and downloading and reading something and I can have several tabs open, we need a process for each one of those. So a process is a program that's running under the authority of the shell. And when a process makes a request for resources, the request is a thread. So the thread is a single task. So for instance, if I print this, that'll go off on its own thread and print. I can start typing again. Because you notice with a lot of programs, you can have it sending email while you're typing an email. You know, you can have multiple things happening on your computer. I'm sharing my screen, which is being streamed to Zoom and back and being recorded. And I'm reading my this, and I could be typing all this at the same time. So this would be a process. Each of these would be a thread. So it could be that each of these you could consider a thread. I don't know if they're actually threads. No, they're tasks, which is a thread. So sometimes a process is called an instance. A process with more than one thread is called multi-threading. So we have all kinds of things that are multi-threaded. Many of our programs are multi-threaded because quite often we're doing more than one thing in the same program. Moving on to the next knowledge check. Knowledge check. Okay, we're going to skip the knowledge check. Logs. I think we have a thing on that. Resource monitor. There we go. Let's look at resource monitor. So resource monitor is attached to task. Is it attached to task manager? We've looked at task manager. We've looked at that. I think resource monitor is part of that now. I lose track between all these operating system changes. Oh, there it is. Resource monitor. If you go ahead and type in resource monitor, it'll bring up resource monitor. So this is similar to what we're looking at in the tasks thing, but now we're seeing, oh my goodness, look at all these little guys. It's showing this particular process. This little guy, whatever that is, has 250 threads. Firefox has, let's see, where do you go? Firefox has 71 threads going on. So this is showing us all of our threads. We're running at maximum frequency, which means our processor is not being clocked down. And we're using 44% CPU usage. Well, part of that is probably just that I'm looking at it. That will take a lot of CPU usage. You want to know what's going on with your disk? Well, here it is. Here's all our stuff. We're doing stuff to disk. What's going on with our network? Well, there's our stuff going on with our network. Memory? Yep, we've used 67% of the physical memory. So there are a lot of things going on. You can specifically look at just the CPU stuff. Look at all the memory stuff. Oh my goodness, look at all that. So this is in use. Here's where we're making changes. The CPU is sending things in and out of itself and say, oh, stick this over here for a minute. I need to do something else. Standby just means that it's ready to be used. It's cached information that's not being used right now. This is what the processor is actually like. Oh, I need to add 1 and 1 and get 2. And this is what's left over. Well, it doesn't look like much left over, is it? Well, I am running several things here. I've got Task Manager and this and all these programs, but my computer's running fine. If you get, up to 70, 80 used physical memory, you're going to experience some slowdowns. So 16 is a good spot to be unless you're going to do a lot of stuff at once. I have 64 on mine at home because it didn't cost much more money to go from 16 to 32. It was like $10 more to go to 64. So I did, just because I could. All right, so there are some pretty things that we can look at. Let's go on here. Yeah, we've looked at Task Manager already. Let's skate by here. We have a lab on System Restore. So by default, interestingly enough, System Restore is not turned on, which I find interesting. It used to be. What is System Restore? That's a good question. Oh, there is a System Restore. It's probably I turned it on when I was in a lab or something, when I was doing something. So System Restore keeps a snapshot of files, like if you install a new program or you install a new device, like you plug in a hover cam. You can use System Restore to go and you plug in the hover cam and your whole computer goes. You can use System Restore to move back to before you install the hover cam. Or you got some Windows updates that crashed your system, which can happen. You can use System Restore to go back, but it's not turned on by default. So you'd think that turning it on would be right here, wouldn't you? That's what I would think, right? But it's not anywhere near here, which I find interesting. I'm trying to remember where it is now. System information, system configuration.
Isn't it just System Restore point too?
Well, you can, but you have to turn it on in the first place.
Oh.
Oh, and I should look it up. Turn on BitLocker, show more options, restore previous version. I'd have to look it up. That'd be a good project. Look up how you turn on the restore point. I would have done it, here because I probably did it in a class, but right off the top of my head, I don't remember where it is. So what do? You Google it. And we'll say, and pretty soon we're going to say, oh, we're going to AI this, instead of Googling things. Turn on, my ad block updated on me. All right, turn on System Restore or System Protection, Windows 11. And look at there, Control Panel, Recovery. There we go. Is anything in the control panel anymore? Not very much. They're moving everything to settings. Well, that's not exactly what we're looking for, is it? System Restore. Oh, maybe we do go to Recovery. Let's see what Recovery says. Because I do move things around and I forget where things are. We don't want to reset the PC. You can reset your PC, but maybe not all your programs will work. Okay, well, I'm going to pause my video. Okay, I looked it up and then I didn't find the right answer. So I typed in System Restore, and then I remembered that it actually is under create a restore point, but that's not really what we're doing. You can create a restore point at that point, or you can also turn on or off the System Restore. So you would configure it, and you have to be an administrator to do this. I think by default it's turned off. I would have turned this on in some class or another that I did. So it does use up extra disk space. Windows updates and things are much more reliable than they were. So is it as important to have System Restore? I haven't had to use system restore in quite some time. If it's to the point where I need to use a system restore quite often, the best option is just to wipe the computer out and reload the operating system, because that will fix any issue. That's the nuclear option. It's like DEFCON 5. So I really haven't used this much recently. It is an option though. So the registry editor, let's look at the registry editor real quick. There we go. We have a lab that works on this. I'm just going to look at it on my local machine. Do not do this on your regular computer. So it's divided up into several pieces, and that's what they're talking about here. Hardware, software, security data. We're almost, oh, that's not the right one. It's going in a different order. I was going to say classes root is the one we never touch. You never touch this one directly. Sometimes you touch this one. Sometimes you touch this one. The one used the most often is HKey local machine. That's the local machine settings. Sometimes you have a setting that's just for you. That's HKey current user. Current config is anything that's dynamic that the computer found about in this session. Those are the ones mostly. Classes root has all the file extensions, and it says, oh, if this is a ACCDB file, it uses access to open it. But you don't ever go in here to change that. If you want to change extensions that open files, you do File Explorer. So you only go into the registry if you have to fix something. And you want to make sure that if you are going into the registry to change something, that you back up the key or whatever it is you're doing. And we do have a lab we'll look at later. Anyway, so it's like a last resort. How do you solve a problem? Identify the problem. Well, we've just started doing that. As we were talking, we were dividing it between hardware and software. Okay, well, if the problem occurs and the computer doesn't quite get started, where's the problem likely going to be? Could be hard. I'm sorry. The operating system has just gotten started. You see the little spinny thing, but then it locks up. Oh, how can you divide that between hardware and software? You really can't, because it could be hardware stopping it. It could be the operating system. That's a tough one. If the computer gets all the way up to the point where you can log in and you get to your desktop and then things stop working, well, if it's a particular program, if only Word doesn't work or only PowerPoint doesn't work. So one of the things you want to do before you call tech support is try different things. Restart your computer. So once you've established that, okay, it looks like Word is not working, but everything else is working fine, you've established a theory. Probably something happened with Word. It could be you have a corrupted file that you're working with. So we're going to test our theory. If we think it's a corrupted file, then maybe you make a copy of that file and try opening that one up. Or you try opening the file and save it as, or you reinstall Office. So that's, can you test your theory without actually trying to fix the problem? Sometimes you can't. You just have to try things sometimes until you narrow down where the issue is. But first you try to figure out, okay, narrow it down as much as you can. Then you test it if you can. And if that fixes the problem, it fixes the problem. Then restart the computer to make sure it actually is fixed. I have done that. I've fixed computers at people's houses. Went home and they called me up. Oh, we shut it down and then turned it on the next day and then it didn't work. It's like, oh, darn, I didn't test it out before I left. And if you're in a help desk situation, you document what you found. It's always good to take this moment as a moment of training for a user. If there's something they could have done to prevent it, and users always think that they've caused the problem, which is why it's sometimes hard to get the information out of them because they feel guilty if they have actually done something stupid, but they think they've done something stupid when they may have just been using it just fine. So that's a good time to do some on-the-spot training. Say, this may not happen if you restart your computer every couple of days or something, give them some, a little bit of training. And don't make people feel stupid. We do not want to, we know more than they do, and that's fine. That's our job. Okay, we don't need to particularly pay attention with that. Sluggish performance, yeah. I think we've done the basics of all that. So we've got a better idea of how the operating system is divided up. if we get to the point where the desktop shows up, the odds are good, the operating system is fine. At that point, we're probably dealing with something with the applications. If it gets stuck before we get to the desktop, it could be the operating system, it could be the hardware. You know, how do you find out? Reinstall the operating system? No, you can start in safe mode. You can try starting it in safe mode, and then if it starts that way, then maybe there was a new driver or something that was on there. How about we know the difference now between hardware, starting the operating system. When the desktop shows up, the operating system is working. If there's an issue at that point, it's most likely an application. So at least we've started dividing things up. And how you learn how to troubleshoot things is to troubleshoot things. If your friends are having trouble, help them out. See if you can figure it out. Google it. If you don't know the answer, make one up, right?
Yeah,
Yeah, that's what I'm thinking. No, don't be afraid to say, I don't know the answer, but I'll find out. I'll ask somebody, I'll Google it, I'll look it up. There's nothing wrong with not knowing the answer. You can't be expected to know everything. I'm forever in my class, just like right now, I couldn't remember where the system recovery was, so I looked it up. You know, I couldn't remember where it was, but then I saw it and it's like, oh yeah, that's where it is. You can't memorize or remember anything. Don't be afraid to admit that you're not sure what's going on and ask questions. That's part of learning and that's part of everyday life. All right, let's stop recording.